Hello students, in this video we'll be learning about the distance formula and we'll solve a few problems from exercise 7.1. First let's look at what is the distance formula. Let's say you have your Cartesian plane. This is y, this is your x-axis and this is our origin. Let's say we have 2 points, one over here which we call as P, x1 comma y1, and there's another point over here which we'll call as Q, write it over here, Q, and I'll mark this as x2 comma y2. Okay, so what I'm trying to show over here, there are 2 points. One is P, I'm just giving it a name P to highlight the fact that there are 2 coordinates there. The point I've given, the name I've given to the point is P, and the coordinates are x1 comma y1. We don't know what it is, it can be anything. And we have taken another point Q whose coordinates are x2 comma y2. So to distinguish between the two, I've taken x1 x2 y1 y2. Now if we need to find the distance between these 2 points, actually, okay, the distance between 2 points can be given as PQ, or the length between the 2 points. Okay, then we can't be drawing the graph again and again. So for that we have something called as a distance formula. Okay, that makes our life easy. It helps us to find out the distance between 2 points on a Cartesian plane without actually drawing the graph again and again. So that would be a time consuming affair. This would make it very easy. So what is the distance formula? According to the distance formula, okay, if we need to find out the distance between 2 points, then we can just give it as, let's say these points are PQ. Okay, so we give it PQ would be equal to square root of x2 minus x1 whole square, okay, plus y2 minus y1 whole square. Have a look at the distance formula. It says PQ equal to x2 minus square root of x2 minus x1 whole square plus y2 minus y1 whole square. As a matter of fact, this formula is nothing actually but a derivation of the Pythagoras formula. Okay, see, if we need to find out this particular point, no, and if we, let's say if we draw a particular, if we draw a right angle over here, what does this become? This become the, and if we say this is the perpendicular, then this would become, PQ would become the hypotenuse, right? And how do you actually find the hypotenuse? Square of the hypotenuse is equal to the square of the other two sides, sum of the square of the other two sides. Sorry, that would be your hypotenuse square would be your square of the base and the adjacent side. So a square plus b square. Now over here, if we go to derive, this is what we get. So where h square, now if we want to find out h and not h square, that would be square root of h square equal to square root of b square plus a square. Okay, which would be square root of h square is h, which would leave us with square root of b square plus a square. And if we go to find out the coordinates of base and that of your perpendicular side, that is your I would not call this as adjacent, this would be your base and not adjacent, sorry, that would be your perpendicular. I'll take this as a perpendicular because we have learnt it as the perpendicular side, not the adjacent side, sorry. That would be a perpendicular. So if we go to find out the points, what is P and what is B, we would get this. Okay, and B would be actually a difference between the two, that is your base would be a difference between the 2 coordinates, and your perpendicular would be a difference between this y coordinates. So remember, this is nothing but a derivation of your Pythagoras theorem We need not go into the details as to how we got this thing, as long as we remember this. Just remember the fact that if we need to find the distance between any 2 points, okay, and the points are, let's say, A equal to x1 y1 and B is x2 y2, two different points, and if you're taking it A B, then this one will come first, this one will minus this one, and this one will minus this one. Okay, so x2 minus, so always 2 minus 1. Okay, always 2 minus 1. So x2 minus x1, y2 minus 1. And remember, have a look how it is done. It is not x2 and there's no mixing up of x and y. X coordinates are clubbed together, y coordinates are clubbed together. So it is x2 minus x1 and not x2 minus y1 or x1 y1, something like that. Okay, nothing of that sort. X coordinate is grouped together under one square and y coordinates are grouped together under. We have to find out the difference, the square of their differences, and then look to open up this square root sign if we can. Okay, but this is your distance formula. So now let's solve some problems on this distance formula from exercise 7.1. So our first question under exercise 7.1, in fact we will be solving only question 1 and in this video from exercise 7.1. So our first problem under exercise under question 1 from exercise 7.1 is 2, 3 and 4, 1. So we'll just assume this first. Let's say P be 2, 3 and we say Q 4, 1. Okay, be the given points. What we'll do is, because our distance formula deals with x and x1, x2 and y1, y2, what we'll do is first we'll list down what is x1, x2 from here. So we'll say therefore x1 equal to 2, y1 equal to 3 from here, and then we'll say and x2 equal to 4 and y2 equal to 1 from here. Now let's put the distance formula. Distance formula for whom? For PQ, because we need to find the distance between these 2 points that we have assumed. So PQ would be equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is our distance formula. Now let's substitute these values that we have got from our question in this distance formula to find the distance between the 2 points. So square root of, what is our x2? x2 is 4 minus, what is x1? 2 whole close the bracket, raised to whole square, plus y2, what is y2? 1 minus, what is y1? 3 whole square, right? Now we'll look to solve them. 4 minus 2 is 2, so 2 whole square plus 1 minus 3 gives us minus 2 whole square. Now square root of 2 whole square is 4 plus minus 2 whole square gives us positive 4. That gives us square root of 8. Okay, you can write this as then 2 root 2 units. So the distance between the two given points we found as 2 root 2 units. So that would be distance. When we talk about distance, there would be some units. If we are not given the distance units, we can just write 2 root 2 units. That solves our first problem under question 1. Our next problem is minus 5, 7 and minus 1, 3. So once again we'll assume, this time I'll change the letters from P and Q. We always take P and Q. We'll take A. So let A minus 5, 7. You can take any letters you like. And B minus 1, 3 be the given points. Okay. Next, we'll say therefore x1 equal to minus 5, y1 equal to 7 and x2 equal to minus 1 and you have y2 equal to 3. Now let's find out the distance between AB. So AB equal to, write down the distance formula, which is x2 minus x1 whole square plus y2 minus y1 whole square. Let's substitute the values of x and y here. So what is x2? x2 is minus 1 minus x1. x1 is minus 1, minus 5. So in brackets minus 5 whole square, and y2 is 3 minus y1 is minus 7. So whole square. Now we'll look to open up the bracket. So you have minus and minus 5 become plus. So plus 5 minus 1 gives us positive 4 whole square, and plus 3 minus 7 gives us minus 4 whole square. Now we'll open up those brackets. 4 4 16, and here also this minus 4 whole square gives us positive 16, which means we'll get it as square root of 32. Okay, square root of 32 can be further written as 4 root 2 units, and that's how we solve this problem. Our next problem is a comma b and minus a comma minus b. Once again we'll assume, let this time I'll take m, a comma b and n minus a comma minus b be the given points. Now therefore x1 equal to a, y1 equal to b, and x2 equal to minus a, y2 equal to minus b. We apply the distance formula to mn now. Mn equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now we'll substitute the values of x and y. For x2 it is minus a, minus x1 is just a, so minus a whole square, plus y2 is minus b, minus y1 is just b, so minus b whole square. Okay, solving further, minus a gives us minus 2a whole square, plus minus b gives us minus 2b whole square. That would be minus 2a whole square gives us 4a square, plus minus 2b whole square will give us plus 4b square, and that comes under the square root sign. Okay, if we take this common here, 4a square plus b square, we will get 2 square root of a square plus b square units. So that is the answer to this problem. So we've solved question 1, and as discussed we would be solving only one question in this video. So if you've liked this video, please click the like button, share it with your friends and classmates. Please subscribe to the channel and do not forget to click on the bell icon to receive updates whenever a new video is posted. Thanks for watching. See you in the next video.